Let's use what we've learned about arrays of structures and let's do a case study. And a case study just means it's an example that we are going to use that is kind of a real-world example, but it employs the tools that we've learned thus far. So it gives us an opportunity to go back through those tools and use them in an application. And this one's going to be familiar. I have used this Alabama weather station data file already in the several examples, and I want to use it again here. So let's take a look at it again. So I'll bring that up here. And recall that we have the columns here. We have the station ID that's over here. And then that's followed by well, here's the station ID. Okay, then we have the station name, which covers that, and the date. And then we have a bunch of other parameters that show up over here. So those are just numbers. So we're going to make a structure that will contain all of this information, and we're going to read in these records, each one of these records, and we're going to store it into an array of structures. So this case study is all about an array of structures. So in that case, we need to declare some structures that we can use to store the data. And here they are. I've already got these laid out, so I didn't have to type them in. We are using a hierarchical structure because one of the items that we have is actually a date with a month and a day and a year. So I'm going to use this structure date, which we have seen already, and it's just an unsigned integer for the month and the day and the year. Then I have another structure here, which I'm calling weather data. Now for each of those columns, and I guess I could bring them up again briefly here, for each one of these things, then I've got an item. Okay, so I've got a string for the station code, the first field over here. Then for the station name, that's a string as well, right? So all that stuff is just a string. So I've got a string for the station name. And then I've got a variable called timestamp that's a type date. So that's going to be the month, the day, and the year, and that shows up right there. Then all the remainder fields, those are just real numbers. Okay, so I'm just going to make some float variables for all of those other 8 columns, and that's what you see here. So that's going to be the structure. So this is going to match one of the data records that comes from the weather station data file. Now, I'm going to use the data file that has all of the bad data records filtered out for the temperatures, then for the temperatures and the precipitation. So this data file is only going to contain the good data, and if I scroll down a little bit here, you can see that I'm calling this the filtered Alabama weather station data.txt. And again, we created this filtered data file in when we were looking at files in previous videos. Now, going back up, from those earlier examples, I know that there are exactly 3174 data records in the file. So I just remembered that. I'm going to use a constant here, just a constant integer records, so that if I were to use this program for the same data, but say for a different year or a different month, then I could change this number easily. I'm also guessing, all right? Actually, well, I've got the data. I know there's that many in there, but I'm kind of taking a guess here as well. We can always read in the file and we can count the records, and we'll do that. But for my purposes, I do want to make this constant so I can change it easily in the program further down. And I'm just going to set it to 3200, which is an approximation of how many records I'm going to need. Okay, and from experience, I know that there are more than 3,000 because I had an error previously when I guessed 3,000. I'm going to have a function that's going to print out one of the data records. So it's called print record, and you can see it takes a type weather data, which is the structure, and the formal parameter is just called record. So I'll have a function to print out one line from the file. Now, let's look at the variables. The array of structures shows up right here. So you see we use the same syntax that we would use with any other array, one-dimensional array, but this time the type is going to be the weather data type. So that's now a structured type that we'll be using. Then I've got just the name of the array and how many records it has. And again, I'm using that constant. So that's going to be the same thing as 3200. And if I hover over it, you can see that in Visual Studio it tells you that there's exactly 3,200 of those in there, or records is 3,200. Okay, now I have some other stuff I need to read in the data. So I've got some string variables here for the data line, and the data line, the station name, the date, and then I've got actual variables here that I can also use for the 8 geophysical parameters that are part of the data record. And you'll see how I use those as we go further in the program. To get started with this, we are working with a file, so let's just quickly review that. I want to open up my data file as an input file, so I need to use ifstream and give it the name for the file pointer. And then I've just got the open statement here, and I'm running a Windows operating system, so it's got the C. The C drive, as typically all Windows machines do, and that's just the location and name of my data file. In order to make sure that it did open correctly, I've got the usual if statement here. So if it's not opened, then I'll print out a message and I'll just return and the program terminates. If it did open, then I'll print out that the data file is opened. Now, remember the first 2 lines of the data file don't contain any data, right? So we just have the headers here and we have the dashed lines. So those are not data. And I'm just going to read those in and discard them because I'm not going to need them. So this get line will read in the column headings, and this get line is going to read in the dashes. So I'm just going to ignore those. So that brings us down to here. To begin with, what I want to do is to read that first data line, and I want to separate it out and store it into one of my arrays of structures. So let's put the code in here to do that. To start with, we still just need to do a get line. Oh, wait, I don't want to do a get line in that case. I want to read the data from the input buffer. So I'm going to use the input buffer approach. Alternately, you could just do the get line. You could copy that and paste it down here. And you could use the substring functions, the find, and all those other string operations to take that record apart and store it into the structure. I'm going to use the input buffer method because I think it's more straightforward. So let's start with that. Let's process that first record from the data file. So the way I want to read this in is I want to start on the left-hand side of the record, and I want to read in this station name first. Okay, then I want to read in this long station name, then followed by all the other items. So let's start by just reading in the station ID or station code. In the structure, you'll see that I declared a string called station code, so that's where I want to put it. What line of code do I need to write here in order to read that data in? Well, here it is. Of course, we're going to use infile. That's the pointer to the file where we're reading the data. And notice how I want to store the data. I have an array of structures. And K starts out with the value 0. So that's the first element of my array. So K is 0 to begin with. So I'm going to store this first record into my AL stations array at index 0. Then I'm going to put in one item at a time, one member element at a time that will go into the structure type that I declared. So the station code is the first one. So the way that I write this is I just use the name of the array of structures, and I use the index, and then I use the dot. So this is the same as what we did earlier, where we did not have an array. We just had the name of the variable. We had a dot. But now we've got an array. We have an array, so we need to add on to this by using an index for each of the so we can get to each of the elements of our array of structures. So this will read in the station code for index 0. So that's part of the structure for the first item. Then the next item that we need is we need to get the station name. Okay, so the station name. Now the thing about the station name, and it's the one item that gave us trouble, or it's kind of complex when we're reading in the data. And if we look at it again, you'll see that with the station name, we have first of all, it's right justified in this field, right? So it shows up, it goes right there. Okay, so we have all of that, and we have these blanks on the left, plus it changes as we look at different stations. So some have long names, and some have short names, like this one does, Addison. So we can't just read in a string for each one of these words, or read in a string for each word, because these will vary. Now, I couldn't read in 4 strings here to get the Bankhead lock and dam, because later on I would just have one thing to read in, which is Addison. So the way that I want to read this in is to read in one character at a time. So I want to start over here. Okay, so all the way over here on the left side, and I want to read one character at a time until I get to the end. Now, these are all constant, and that all the records are identical. So I know that there are exactly 50 characters for the station name. Okay, if you wanted to count them, you could, but there are 50 of them. So that tells me exactly how many characters I need to read in. I'm going to use a for loop to read that name in one character at a time. And I'm going to just go ahead and put that for loop in here, and I'll get the comment that goes with it. I'll copy that, and I'll paste it in here. So this is going to read in the station name. All right, now, it looks like I have an identifier that's undefined, so let me locate that error. So if I look back, I find out I have a station name declared not name. So let's fix that. I'll just copy this and paste it down here. Okay, so instead of name, we have station name there. Now, station name is just a regular string variable up here. Okay, it's just a regular string variable. Within the structure itself, then I've got another thing called station name up there. Okay, now that might be a little bit confusing. Maybe that's why I had separate variables for that. So I tell you what, let's try to avoid the confusion. I've got station name up there within the structure, and this simple variable name here, I don't want to duplicate that. Okay, so let's fix this one more time here. So let's just call that S name, so that we don't get this confused with the element of our structure. So let me one more time make this change. So I'll copy that here, and I'm going to make this whole thing here S name to avoid the confusion. So let's paste that in here and in here. Okay, so now we have S name as a regular string, whereas station name is part of our structure. This loop, and notice I'm going from 18 to 68. I could have easily gone from I equals 1 to 50, but for some reason I was just looking at those column headings, and if I count over, then I know that first line right there, that first character, that's going to be at location number 18, and the last one over here is going to be at 68. So that's 50 in width, right? So it's the same thing. You could put I equals 1 to 50 there, and it would give you exactly the same result, all right? But either way, I'm going to read in one letter at a time with get. Okay, so I'm going to get the first letter, and then I will concatenate it onto S name. Okay, now S name starts out as just a blank string. There's nothing in there. So I'm going to go through and read from the input buffer with get one letter. I'll concatenate it onto S name, and then when I'm finished, then I will have the entire name of my station stored in variable S name. If I want to then put it into my structure, then I can copy it using this line. So let's put the Alabama stations K again, all right? So I'm using the index just like before, but this time I want to fill in the station name field, and I'll copy S name into it. So this takes the entire name that was put together with that for loop, and it stores it into the station name member element of our structure. So now I have put the code up here, the station code, I've stored that, and I've stored the station name. So I have two of the hard things out of the way. Now the next thing is the date. So let's see if we can get the date. And as it turns out, the date is a number, but I'd like to divide it up. I'd like to get the year, and I'd separate that out from the month and separate that out from the day. So I'd like to split that apart into the month, day, and year. So I am going to go ahead and read that in as a string. So let's do that next. So we'll just use the code here to do that, simple code. So we'll read the date in as a string, and it's very easy. Just we'll do in file date, and I know that works just fine because there are no spaces in there. So when I read in file date, then it goes all the way through here until it finds a space, so it'll stop right there. Okay, so that'll give me the date, and it will be a string. Then, and let's look, make sure, okay, date is a string. There it is right there, all right. So then I have read in the date, but I want to separate the month, day, and year. So I can just use my substring functions for that. So let's look at those. So let's put those right here. And I want to convert the fields, and well, I want to read them. I want to read in the date. I want to separate out the month, the day, and the year, and I want to convert each one to an integer type. It really turned out to be not essential that I did that. I could have treated the individual fields. I could treat the month as a string, the day as a string, and the year had I wanted to, but I just chose to convert them to a type integer in this case. Now, let's look at the portion of the structure where I want to store the date. And that's probably why I did this, why I did the conversion. That's because I had a structure called date already declared, and those were all unsigned integers. Okay, so that's one reason I wanted to convert it. Then inside my structure, I have a variable called timestamp, and it's a type date. So it will have month, day, and year. So I want to separate those out. Here are the 3 lines that I need to do that. First of all, I want to access the timestamp part of my structure and then the month part of the timestamp, right? So I use the 2 dot notation here. So this notation is beginning to get sort of long because we have now an array of structures, so we need to use the square brackets to index into a particular element of the array. Then we use the dot notation, and the first dot gives us the major structure element, member element that I want. And since that is a hierarchical structure, I use another dot to get down to the month portion. So in order to store the month, I need this whole thing. So that stores the month part of the day into the kth element of the array, Alabama stations. Now, same thing for the day and same thing for the year. On the right side, I am just doing a conversion. Okay, so the date for I'm pulling out the substring. I want to go to position 4, and I want to get 2 letters, 2 characters. So that would pick up the month. Okay, so here, notice that's position 4, and the 03 is for March. Okay, so I get 2 characters. That gives me the month. The next one, I want to go to position 6. That's all the way over here, and I'll pull out the day. So the 01 would give me the day. And the year itself, well, that starts over here. So at the very beginning of date, so I go to 0 and I pull out 4 characters there. So I will extract using the substring those 3 items. Then I'm going to use the S2I, string to integer conversion. That converts the string to an integer, and that will then take this type string that I just extracted. Substring gives you a string. So it takes those strings, converts them to integers, and stores them into my structure. And it's okay that I can store an integer into an unsigned integer. It shouldn't care. Now, that takes care of the date. What's left? Well, the thing that's left now will be these 8 numbers that show up across here. So I want to read those in. And that's easy to do because I know that all the the data that I want that's good is already filtered out. I didn't filter out these other fields. I'm not concerned about those in this example. But my precipitation is good everywhere, and the Tmax and Tmin, those are good everywhere. So I just need to read those in as numbers, and I've declared them to be a type double up here. So in the structure itself, one more time, here are the types to go with those 8 different columns of numbers. It's easy to read those in from the input buffer. All we need to do is just use our in-file statement. So let's put that here. So I'll just drop the code right here to do that. And it says now read in the geophysical data as double. All right, now I might have a typo here. Let me go look at my structure up at the top. It's called AWND. Okay, so I do have a typo there. Okay, so that's not unusual for me. So let's change that to an A. Good. It's AWND. So 2 typos. So that's the wind. All right, so now we just continue to read across from left to right, and we'll get the remainder of these data items. Okay, so we just finished off the date. Now we just need to have 8 inputs to read in those 8 numbers. And that's what this does. Okay, we pick up the MDPR, followed by the DAPR, followed by here's the precipitation, and then the Tmax and all the way out. So this statement then just uses the in-file file pointer to read in all the data from the file. So that's how we do it. That reads one entire record from the file, and it stores it into one of the elements of our structure, the first one, k = 0. Now that we've done this, we've processed one record from the file, we need to verify that this actually works before we go any further. So we need to print out all the data that we just stored into that record. I have a function that I've already written that will print out one data record. So if we scroll down, then you'll see the function. So here we have it, and this is very similar to some of the print records that the print record function that we used for our student record in earlier videos. So this one is going to print out the data, so it can just be a type void. It doesn't need to return anything. And the function is going to accept one formal parameter, which is type weather data. So notice that it is not it's not going to take in an entire array. It just takes in one record. Inside the function, then we will print out all of those elements. So we'll print out the station ID, and we reference that with the dot notation again, and we'll print out the station name here, again using the dot notation. The date of the measurement, well, that's a hierarchical structure. Okay, so we have to use the double dot notation to print out the month and the day and the year, and you've seen this before. And then just a regular cout statement here to print out each of those additional 8 numbers. So that will just print those to the screen, and then the function returns. Well, I do already have the prototype for that one up here. So we'll scroll back up and see there's the prototype. So now I just need to call print record to print out the data that I have stored into my first index of my array of structures. Okay, so let's just call print record right there. Okay, so let's put the code there, and here we go. Now, I am just going to call it with one record. I have to. I can't send the entire array. And which one do I want? Well, I want to send in the one where k is equal to 0 because we just filled that up with data. So this now illustrates how we can take one record from our data file and we can store it into the first index of an array of structures. I've got a system pause here because we need to test the program at this point. We don't want to go ahead and jump into the while loop and finish everything out until we make sure this works. So let's compile the program and run it to see to make sure everything is working properly. Now let's bring over the output window and let's look at the output. And here you see that it looks like everything worked. Here we have the output from our print record. So we have the station ID, the station name shows up here. And we have the date, and it's divided into month, day, and year. And here are the other 8 numbers that we read from the file. So if we wanted to double check that, we could just bring these up, and we should double check it. So you can see, sure enough, precipitation is 15, and the temperatures are 82 and 53. So everything checks out. Now that we know that it's working, we can just put all of this code inside a loop, and we can loop through the entire data file, and we can fill up the array of structures called Alabama stations. So let's just take all of this code and let's put it inside a loop. If we scroll down a little bit, you'll see that there's a loop that's already waiting for the code. So here we have the while loop that begins at the top of the loop, and I've got comments indicating what we want to do. We just did that for one data record. And then at the bottom, we've got some little housekeeping lines of code we need in order to prepare to go through the loop a second time. Okay, so let's just do a simple copy here. So which way is the best way to go? I'll tell you what, let's take the top of the loop here, and I'm going to just cut that, and I'll move it up to here where we start to read in the data. Okay, so let's put it right there. So that will begin the loop, and now let's get the bottom part of the loop, and I'll just cut that and paste it after we have read in all of the data that we want to read in. So I'll put that here. So now we have all of the code in a while loop. Let's indent it so that it looks the way it should. Okay, so we have all that, and I'll just tab over. And now we have all the code in a loop. So now we just go through the loop until we get to the end of the file. We'll read in the station code, and we'll read in the station name and all the other stuff. And at the end of the loop, we will increment our index k. And I've got a counter in here, which I don't really need, so it doesn't hurt to leave it in there. And then we will reset the station name. The S name has to be reset to the empty string, because when I go through the for loop, I want to concatenate a new station name using that variable. So I need to reset that to the empty string before we go back to the top of the loop. This now will go through the entire data file, and it will read all the data into our Alabama station's structured array, or our array of structures. I should go ahead and remove these other things, these comments. I don't need those now that we just put the loop around everything up above. So let's remove that extra stuff. And then once we're all done, we can close out the file. So what I have now is the following. I have a loop which will go through the data file. It will pick up all of the data. It will store it into our array of structures. And then at the end, we can print some information out just to make sure it worked. Well, to do that, let's just print out several of our data structures. So we'll close the file. We're done with that. And here's just a for loop that prints out 10 of the records. Now we have over 3,000. We don't want to see all 3,000. So let's just print out 10 of them, and then we will stop. So I'm going to move the system pause away. I'm just going to move it from there until after we print out our 10 structures, 10 items, and we'll look at the rest of the program a bit later. So let's try this out. Now, I'm going to check this one more time. It looks like we have everything in order. And I'll take this print record out. We just used that for 1. Now I have the print record inside a loop, so we'll print out 10, starting at index 0. So now let's compile the program and run it once again. The program's ready, so let's look at the output. I'll bring that over. And you can see all the preliminary stuff. Here is our first record, and we can tell it's the first one because it's March the 1st, so that's easy. And then the for loop prints out 10 of them, and the easy way to tell that it's moving through our data structure is to see the date changes. So the day goes from 1, 2, 3, and we see the information that's printed out. So we have the station ID again, we have the station name, and it'll be the same for all 10 of these beginning records. But we do print out a total of 10 records from our array of structures. Okay, there's the last one, March the 10th. So now this works. We can be assured that we have now loaded in all of the data, all 3,174 lines. All of that has been loaded into our array of structures, which we are calling Alabama stations. Now that we have loaded all that data into an array, we can pass that array around and we can do operations on that code. We can do all kinds of analyses because everything is grouped together. We have the structure that has everything in a single record all grouped together in one unit, and that's what this structure does. So it helps you to organize the information as a unit, and then you can pass that information around and operate on it easily. This video now is running close to 30 minutes, so I want to stop the video here, and I'll pick up the program in the next video where we'll actually use a function to sort the data, and we will enter some information like the name of the station and the month, the day, and the year, and we will search through the data to pick out the data from that station on that date. So that's coming up in the next video, but we will stop this one here.